In this video, Arduino Nano is used to control both direction and speed of a DC motor rotation. The DC motor is interfaced to the Nano using IC L293D driver. The video also shows DC motor control based on ambient temperature. The L293D is a quadruple high current half-edge driver, which is designed to provide bidirectional drive currents of up to 600 mA at voltages from 4.5 to 36 volts. This IC is designed to drive inductive loads such as relays, solenoids, DC and stepper motors. This IC has 4 driver channels to handle 2 DC motors. So each motor can be driven either clockwise or counterclockwise direction. In this video, channels 3 and 4 will be used to connect one DC motor to the IC. Pin 15 will be connected to one output digital pin of the Arduino to provide one direction of rotation. Pin 10 will be connected to another digital output to provide another direction for the rotation. Pin 9, the enable pin, is normally connected to a PWM pin of the Arduino. A digital pulse through this pin will enable the 2 channels 3 and 4, while an analog signal here between 0 and 5 volts will enable the 2 channels and also control the speed of rotation of the motor. The implemented circuit is shown here. The L293D IC is interfaced with the Arduino using 3 digital pins. We have a DC motor fan connected to the L293. We also have a thermistor connected to analog pin of the Arduino, and we have a potentiometer connected to another analog line. Finally, we have an LED connected to a digital output pin of the Arduino. In this first demo, the DC motor will be rotated clockwise and counterclockwise at variable speeds. In this next demo, a thermistor is used to switch on the motor when temperature increases beyond a certain threshold. Finally, the rotation speed of the motor is controlled by the 10K pot. This is the C++ code related to controlling the DC motor through the thermistor. In the loop function, the first thing we do is to get the potentiometer value and map it into a new set of values between 0 and 255. Then we get the temperature reading from the thermistor and convert this temperature into Celsius. Then we check the value of the temperature against a threshold, and if the temperature is greater than this threshold, then we call a function fan on and send to this function the pot value. Inside function fan on, we receive the pot value and store it into this variable fan speed, and inside the function the first thing we do is to turn on the LED and then enable the enable pin of the L293 by sending the integer value of fan speed. This value is between 0 and 255. That will determine the speed of rotation. 0 will be no rotation, 255 will be maximum rotation. Next, we start the rotation in one direction, apply some delay, and then disable the enable pin of the L293. DC motors work well with robotics because they allow the robot to be battery operated, which offers great advantages for a variety of robotic applications.